Hello, and welcome to my final presentation. I'll be talking today about a paper called Classification of Sentiment Reviews Using N-gram Machine Learning Approach. This paper aims to compare different N-gram approaches for sentiment analysis, one of the most common tasks in the field of natural language processing. For this purpose, we aim to classify movie reviews as either positive or negative. Before getting into the paper, a little bit of background. Let's think about how we would approach the task of sentiment analysis. The first approach might be the bag of words approach. In this approach, we examine every word independently. If the words in a review are used in lots of positive reviews, we can classify that as a positive review. For example, the word great is used in lots of positive reviews. Because of this, we will classify a review such as, "This movie was great," as a positive review. There are, however, drawbacks to this approach. These limitations are largely due to negations. If a review has "not good" in it, our last approach, the unigram, would mark it as a positive review, because good would be evaluated independently of not. A bigram would solve this problem. A bigram will explore every 2 words, and a trigram will explore every 3. We can also combine these n-grams to create a 1-2-gram, which is a union of a unigram and a bigram. Similarly, we can create a 2-3-gram and a 1-2-3-gram. In this paper, the authors aim to determine which n-gram will lead to a more accurate classification. To this end, they will test each n-gram approach on a variety of classifiers. The authors hypothesized that higher order n-grams will have a better accuracy score than lower order n-grams because they will be able to understand higher level concepts such as negation. To test their hypothesis, the authors used 4 different classification algorithms: naive Bayes, maximum entropy, support vector machine, and stochastic gradient descent. These results were similar for all cases. The steps that the authors followed are the following. Firstly, they would load the dataset. They would then pre-process the data, which consists of removing all the stop words. Stop words are words that do not have a direct correlation to sentiment. They would then vectorize the reviews to get the relative frequency of words in reviews. Then they would train one of the classifiers using the training data, test it using the test data set, and then they would find the accuracy of that test. Here are the results that they showed. We can actually see that the hypothesis of the authors is contradicted. In these graphs, the y-axis is the classification accuracy, and the x-axis shows different n-grams. Here we can see that the accuracy for these n-grams actually goes down as we move to higher order n-grams. So as we go from a unigram to a bigram to a trigram, the accuracy decreases. This effect is even more noticeable in the SVM and the SGD cases. So hold on, this hypothesis was contradicted, but why? The work by the authors actually ends here. To figure out why this was, I revisited their process. I noticed that the second step of their process was the pre-processing, which consists of the stop word removal. Stop words are words that by themselves do not contain much sentiment. These are words such as him, don't, were, no, not. I believe that even though these words do not directly affect the sentiment in a review, they contribute to higher level concepts, and their removal will detract from the accuracy of higher order n-gram models. Here's my hypothesis. From this, I hypothesize that the author's removal of stop words is detrimental to the accuracy of their model. To determine if this was true, I implemented their model exactly as they did. I ran it once as is and collected the data from that. I then restarted it, this time keeping the stop words in the reviews. I compared the accurate results from these 2 experiments. Again, the y-axis is the accuracy and the x-axis is the n-gram. Here, the orange line is my proposed algorithm, which keeps the stop words in the reviews. The blue line is the author's approach, which removed the stop words during the pre-processing phase. Here we can see that while the author's model is made worse by higher order n-gram models, the proposed model's accuracy remains similar to that of a unigram. The results for the SVM and SGD show the same phenomenon. I believe that these results support my hypothesis.